Well, the first thing to know about ASN1 is there are 13 different string types. Tragically, OpenSSL did not have this part. Like, I was messing around with them, and OpenSSL segfaulted. And I wasn't even trying. That's like the best feeling ever. It turns out it was not exploitable. If you have string types that have to have 4 characters each, so they have to be some offset of 4, or at least if they were legitimately generated, they'd have some offset of 4. In my case, I basically was able to get it to jump over the termination byte. And in any normally written system, this would be game over because it would copy into memory, but it turned out that OpenSSL had some, for once in its life, had a paranoid design and was not exploitable. Now, here's the thing. There are many ways of ending a string of text. ASN1 has an explicit length field, so this is 15 bytes long. And most C APIs are null terminated. So if the string ends with 0, it says, okay, this is the end of what I have to parse. So if you have a certificate that says, say, www.defcon.org, null www.oxoo.com, OpenSSL is going to think, oh, that's part of the oxoo.com. I better check out that owner. But it turns out the certificate is parsed by every browser as www.defcon.org. So this was actually found by Moxie, Marlin, Spike, and I. And amusingly enough, we exposed it at the same conference within like 3 minutes of each other. So for all the things you've heard, sticking a null in was actually the most reliable attack. And I could have gone ahead and gotten a cert for star.docsparrow.com, and that would have worked on everything. So the null one was actually fixed all over the place. Pretty much every browser on the planet no longer accepts stars. We're finding various like mail servers and mail clients, and it's a mess picking up all the things that hit nulls. So, but it's better than it could be. Anyway, long story short, since I've only got a few minutes before I got to give up the stage. Got 5 minutes? Okay. What do? There is a point with the technology that you just say, this thing has been failing so badly, so frequently, so messily for a decade, we have to do better. The reason I changed my mind on DNSSEC is not because I think the technology is beautiful, because it's kind of messy. It turns out, underneath all the messiness, there is actually a workable protocol inside. And that workable protocol just doesn't have all this complexity. There's no ASN1. There's none of these delegation problems. There's none of these exclusionary problems. We were already basing our security on DNS, so it's no big change to use DNSSEC. We're already there. If your DNS is hacked, you're in a lot of trouble today. There's no deviation. The reason I want to see DNSSEC actually get deployed is because at the end of the day, instead of having this huge impedance mismatch, huge extra technological layer, all of this work, I just want to write a line of code that says, give me this person's PGP key. Give me the IPsec key for this IP address. Give me the SSH fingerprint. I want one line of code, and I don't want to have to think about OpenSSL again. That's what DNSSEC, done right, is going to be able to do. What I showed you today is a technology that has spent 10 years not solving our authentication problems. In about 6 months, the root is going to be signed. And a couple of top-level domains are going to be securable. I don't know if com is going to be. I do know that org is going to make fun of them every single day until they get on board. So I think they'll actually figure it out. Here's how what's going to happen is very simple. Big guys are not going to be able to move fast. We can code whatever the hell we feel like. So my hope is to see over the 6 months after the root is signed that we actually start seeing bubbling up, bottom up, interesting secure technologies that before we never could have written because, frankly, it took so much work and so many teams and so much knowledge. But now, all of the hard security stuff is just going to be a single line of code. I need a PGP key. You don't have to figure out OpenSSL. You just need to run this one line. So go write cool stuff once we get the root signed. That's what I got.
Dan, did you want to take maybe 1 or 2 questions?
Yeah, I can take some questions.
Okay, if anybody has a question, please use one of the microphones in the aisles. Do we have any questions? Yep. Yeah. And just guys, a reminder, if you are exiting because we still have questions, please exit as quietly as you can.
Hi.
Okay, go ahead.
I don't really have a question, but I think a nice remark, because you also mentioned Startcom. And I was evaluating Startcom as a way to certify test servers and everything, because they have these nice, cheap certificates for nothing. And what they do is they always add a subject alternative name of your pure domain name. So if you certify mystupidtestserver.mycompany.com, they add mycompany.com to the certificate.
It will fail.
I agree.
And DNSSEC, it just happens not to have those flaws. The thing to realize is DNS has been a working delegation system for 25 years and a working exclusion system for 10.
Yep.
And that level of success, I wish authentication worked as well as DNS did, because mostly DNS just works.
Oh, guys?
Thanks.
Because I'm sure you'd like